This is question number 1 in the calculator section. Multiply out the brackets and collect the like terms. So we have a pair of brackets here at the front and then our negative 9x term at the end. We're going to deal with the brackets first of all. So we have the x from the first bracket and we multiply that by the second bracket, x minus 5. And then the plus 2 from the first bracket, again multiply the second bracket, x minus 5. And then the negative 9x term that was on the end. So x times x is x squared. Take away x times 5, which is 5x. 2 times x is 2x. Take away 2 times 5, which is 10. And then negative 9x. So we're looking to collect any like terms together. So we can see there's a negative 5x, a plus 2x, and then a negative 9x. Those are the like terms. Our x squared term at the front is on its own, and then the negative 10 also a number on its own. So we'll write down our x squared first of all. The negative 5x, add the 2x, gives us negative 3x, and then negative 3x, take away this 9x, gives us negative 12x. We then have the negative 10 on its own, I should say, which finishes off our simplification and gives us our answer, x squared minus 12x minus 10. This is question number 2 in the calculator section. A company buys machinery worth £750,000. The value of the machinery depreciates by 20% per annum. So that means it falls in value by 20% every year. We're then told that the machinery will be replaced at the end of the year in which its value falls below half of its original value, half of £750,000. After how many years should the machinery be replaced? And you must explain your answer. So the first thing we have to do is work out half of the original value. So that's half of this amount here, 750,000, which is £375,000. Now, because the value of the machinery depreciates by 20% per year, then that means each year it is worth 80% of the value it was at the start of the year. So what we want to do is work out the value of the machinery on a year-by-year basis until the value drops below the £375,000 mark. So we'll do that first of all with year 1. So to find the value after 1 year, we take our starting amount, which is £750,000, and find 80% of that. So to do that in practice, we multiply by 0.8, which is 80% as a decimal. That gives us £600,000. So clearly after 1 year, the machinery hasn't dropped below half of its original value. So what we're to do next is calculate the value after a second year. So we'll take another heading again, year 2 this time. So the starting value at the beginning of year 2 is £600,000. Once again, multiplying by 0.8, which gives us £480,000. So that's the starting value for year 3. And we will continue in this manner until we get our value below £375,000. So that's 480,000, once again multiplied by 0.8, which this time gives us £384,000. So we're pretty close now. It's probably going to be year 4, so we'll just show the working for that to prove it. So in year 4, our starting value is £384,000. £384,000. Once again multiplying by 0.8, and that gives us £307,200. So this is clearly now below half of the original value. If we have a look back, the original value was £750,000. We already worked out what half of that would be, which is £375,000. We were told that the machinery will be replaced at the end of the year in which its value falls below half of its original value. So that's the year we have just worked out. So we can now say that the machinery will be replaced after 4 years. This is question number 3 in the calculator section. We're asked to solve the equation x squared minus 5x minus 2 equals 0. We're asked to give the roots correct to one decimal place. Now often we would solve a quadratic equation of this type by factorising, but this one we're going to use the quadratic formula. So how do we know to use the formula instead of factorising? Well, the first clue is that it's in the calculator paper, and secondly, the fact that we're told to give our roots corrected to one decimal place, that indicates that it probably won't factorise. So we'll start by writing down the formula. X equals negative b plus or minus the square root of the discriminant b squared minus 4ac over 2a. So what we need to do first is identify our a, b and c values. A is the number in front of the x squared term, which in this case is 1x squared. B is the number in front of the x term, which is negative 5. And c is the number on its own at the end, which is negative 2. So substituting those into our formula, we get x equals negative b, which is negative 5, plus or minus, and then it's b squared, so that's negative 5 squared, minus 4 times a, which is 1, times c, which is negative 2. That's all over 2a, which is 2 times 1. So tidying this up a little bit and simplifying where we can, that gives us x equals, then we have two negatives here, negative 5, which means we have a positive, so that's just 5, plus or minus, and then we have the square root of negative 5 squared, which is a positive number, 25, then negative 4 times 1 times negative 2, which again will be positive, and it's 8, over 2 times 1, which is 2. So that then gives us x equals 5 plus or minus the square root of 33 over 2. When solving a quadratic equation, we know that we expect two separate answers. So this is where the plus minus part comes in. This will help us branch our working off into two separate parts. So that then gives us, move this up a bit to give us some space. Firstly, x equals 5 plus the square root of 33 over 2, which will be the first solution. Or, for our second solution, x equals 5, take away the square root of 33 over 2. So if we remember, the question asked us to give our answer correct to one decimal place, which means for the first answer it will be 5.4. Moving on to the second answer, and that one will be negative 0.4. Those are the two solutions to our original quadratic equation, both rounded to one decimal place, so that's the end of the question. question number 4 in the calculator section. A lead cube of side 10 centimetres is melted down. During this process, 8% of the metal is lost. The remaining metal is then made into a cone with radius 8 centimetres. Calculate the height of the cone and then give your answer correct to 2 significant figures. Now the first thing that we're going to have to do is work out the volume of lead we had to begin with. So it was in the form of a cube. So that's the volume of a cube first of all. So the volume of a cube or a cuboid is the length times the breadth times the height of the cuboid or cube. So since it's a cube, all the sides are the same length, so that's 10 times 10 times 10, which gives us the original volume of the cube as 1000 cubic centimetres. This cube of lead is then melted down and recast as a cone, but it tells us that during this process 8% of the lead that we had originally is lost. So what that means is that 92% of the lead that we had to begin with will remain. So we need to work out what 92% of 1000 cubic centimetres is as a start. So we'll give ourselves a bit more room to do that. So that will be 1000 multiplied by 92% as a decimal, which is 0.92. That's a fairly easy one, even without our calculator. That will be 920 cubic centimetres. So what that then is the volume of the cone. Now, if we refer back to the question at this point, we are told that the cone has a radius of 8 centimetres and we are trying to calculate the height of the cone. So what we know that the volume of the cone is 920 and that the radius is 8 centimetres. So if we substitute those values into the formula for the volume of the cone, that will then allow us to work out the height. So the cone volume formula is V equals 1/3 pi r squared times the height. We know that the volume is 920, so that's equal to 1/3 multiplied by pi times the radius squared, which is 8 squared, multiplied by h, the height, which is what we are trying to figure out. So what we are basically trying to do here is rearrange what we have so that h is the subject. So on the left hand side we have this 920. On the right hand side we have 1/3 times pi times 8 squared, which will be 64, multiplied by the height. So if we think of all of this being over 1, then we can multiply with the other fraction, which is 1/3. So that then gives us 64 pi h on the top line, and on the bottom line we get our 3 times the 1, which is 3. So the best thing we could do here is probably just flip the equation round to give us 64 pi h over 3 is equal to 920. So taking this 3 and move it on to the other side, it will change from divide to multiply. So that then gives us 64 pi h equals 920 times 3. Just move this up to give us a bit more space. We want h on its own, so moving the 64 pi to the other side is what we'll do next. So that will leave h on the left hand side. 920 times 3 is 2760, and then the 64 pi, which was times in the h here, will come on to the right hand side and do the opposite, So it will divide. So that then leaves us with a calculation that we can do to work out the height. So it'll be 2,760 divided by 64 pi, which works out to be h equals 13.72711 and so on. We want our answer correct to two significant figures. So that's going to be the first two here, the 1 and the 3. But since the number that comes after the 3 is a 7, means that 3 will be rounded up to a 4. So the height will be 14 centimetres, and that's it corrected to two significant figures. That's our answer and the end of the question. This is question number 5 in the calculator section. We're asked to change the subject of the formula to b, and that formula is a equals 3b squared plus c. So we want b to be the subject of the formula. It means we need to end up with b equals. The first thing that we can do here is just flip the equation around. That will allow us to get the b on the left hand side. So that will be 3b squared plus c is equal to a. Now we want b on its own on the left hand side. The next thing we're going to do is take the plus c, move it onto the right hand side, so it will become negative c, or take away c. So that's 3b squared left on the left, a already on the right, and plus c moving across to become minus c. The next thing we want to try and take to the other side is the number 3, which is multiplying the b squared. So moving that onto the other side, we'll change from a multiplication to a division. So we'll be dividing all of the right hand side, a minus c divided by 3. We have b squared on the left hand side. We want that to become just b, so we need to find a way of removing the squared part. So basically what that's going to mean is taking the square root on both sides. You can think of it another way. You can think of moving the squared onto the other side. So once again, when we cross the equal sign, we do the opposite. So the squared becomes square root. So b will then be the square root of the right hand side, which is the square root of a minus c over 3. We now have b as the subject of the formula, so that's the end of the question. This is question number 6 in the calculator section. We are given two algebraic fractions which we are multiplying, and we're asked to simplify. So the first thing we're going to do is multiply them together. So that gives us x to the power of 6 y cubed on the numerator and y squared x cubed on the denominator. Now the rules of indices tell us that when we are dividing, as we are here with our fraction, that we subtract the indices. So what does that actually mean for the situation we have here? Well, we can think about it like this. If we look at the x's first of all, we have like 6 x's hiding in here, and on the bottom line we have 3 x's hiding in here. So what that means is that the 3 x's on the bottom line can cancel 3 of the x's in the top line, leaving us with x cubed. A similar situation happens with the y's. Again, we have 3 y's hiding in here and 2 y's hiding in here. So that means both of the y's on the bottom line can cancel out 2 of the y's on the top line, which just leaves us with a single y, or y to the power of 1. So effectively what that leaves us with is x cubed and y to the power of 1, which is just y. That's it fully simplified, and that's our final answer. This is question number 7 in the calculator section. We have been given two algebraic fractions which we are expected to add together and then express our answer as a single fraction in its simplest form. Alongside the two fractions, we have been given a couple of mathematical statements which are correct for this situation. But in terms of how we answer this question, they make no impact on what we have to do, so we will just ignore them completely. So the method we're going to use to add the two fractions together is the kiss and smile method, which we'll put down just now. So that involves multiplying the 3 by the x minus 1. Then we have the plus sign, which exists between the two fractions. And then the 5 by the x plus 2, which completes the numerator. And then on the denominator, we have our x plus 2 multiplied by the x minus 1. On the next line, we're going to multiply out the brackets on the numerator. 3 times x is 3x. Take away 3 times 1 is 3. Plus 5 times x, 5x. Plus 5 times 2, which is 10. On the denominator, we will leave the brackets intact in case we can refactorise the numerator once we have simplified it and then cancel, which we don't know yet, but is a possibility. So looking for like terms in the numerator, we have our 3x and then our plus 5x, which will give us 8x, and then the negative 3 add 10, which will give us 7. So that's 8x add 7 over x plus 2 times x minus 1. There is no factorising possible on the numerator, so that is in fact our final answer and the end of the question. This is question number 8 in the calculator section. The shape below is used as a logo in an advertising campaign. So if we look at the diagram, we can see that it's made up of two overlapping circles. We're told that the points C and D, here and here, are the centres of each of the circles, and each circle has a radius of 24 centimetres. AB is a common chord for both circles and is length 30 centimetres. We're then asked to calculate the height of the logo represented by the line PQ. So that's all the way from the top down to the bottom. If we think of this height in sections, then we have P to C, the radius of the top circle, and D to Q, the radius of the bottom circle, which will be the same, 24 centimetres. Then we have this line going from C to the chord, and a similar sort of line on the other side, D to the chord. You can see that the two red lengths and the two blue lengths would add together to give us the total height. So the red lengths we know, 24 centimetres. The blue lengths are the ones that we need to work out. Now this type of question comes in many different forms, but if you've completed plenty of past papers, then eventually it should seem familiar. Pythagoras always plays a part, and in order to use Pythagoras we will need a right-angled triangle. So first of all, realising that the radius can be drawn from the centre point to any point on the circumference, then that should lead us to see that we could draw the radius in here. That then provides us with a right-angled triangle. Now, if we can manage to work out the length from here to here, then along with our radius, this length and this length can be used to figure out the length of the blue line using Pythagoras. Now we already know the radius is 24 centimetres, so that side's 24, and we are told that AB, the common chord, is 30 centimetres. So that then means that the purple line will be half of that, that will be 15 centimetres. Now that will allow us to work out the length of the blue part going from here to here. So I'm going to draw that triangle out again separately so we can have a clear look at it. Performing Pythagoras now will allow us to work out the length of the side, which I have called x. So that's x squared equals the long side squared, take away the other short side squared. So that's 24 squared take away 15 squared. So that gives us x squared equals 576 take away 225, which gives us x squared equals 351. So that means that x will be the square root of 351, which means x equals 18.7 centimetres, rounded to one decimal place. So looking back at our original diagram now, that means that the measurement from here to here is 18.7 centimetres. That also means that from here to here is another 18.7. And since we already know that the radius is 24 from here to here, and again from here to here, then now we have all the parts which make up the height from P to Q. So that will be 24 plus 18.7 plus 18.7 plus another 24. So writing down our working for that gives us, which works out to be 85.4. That's centimetres. That's the height of the logo and the end of the question. This is question number 9 in the calculator section. A Ferris wheel is turning at a steady rate. The height h metres of one of the cars above the ground at a time t seconds is given by the formula h equals 7 plus 5 sine t. Find 2 times during the first turn when the car is at a height of 10.8 metres above the ground. So move this up a bit to give us some space. I think writing down the formula is the best thing to do first here. H equals 7 plus 5 sine t. We are asked to find the 2 times, so that's t we're trying to find, during the first turn when the car is at a height of 10.8 metres. So substituting that 10 point in for the height is how we start. So that's 10.8 equals 7 plus 5 sine t. Rearranging our formula and solving for t is what we want to do. A good start would be getting t onto the left hand side. So we can do that by just flipping the formula around the other way. So that's 7 plus 5 sine t is equal to 10.8. Moving the 7 across to the right hand side will give us 5 sine t equals 10.8. Take away the 7. That then means that 5 sine t is equal to 3.8. The next thing we want to do is move the 5 across. So again, we'll give ourselves a little bit of room for that. That gives us sine t is equal to 3.8 divided by 5. Our next step is to find the inverse of sine of 3.8 over 5 and then use our cast diagram. So when we do that, we get 49.5 degrees. So that's the angle we're going to take to our cast diagram. So we'll move this over a little bit once again to give us space for our cast diagram that we mentioned. So that's all sine, tan, cos. We look at this line here where we had sine t equals 3.8 over 5. 3.8 over 5 is clearly positive. That tells us that our 2 answers will come from the all and sine quadrants. So that means that t, the first value, will just be 49.5. It is in fact seconds, not degrees, because we're talking about time. And in the sine quadrant, it will be 180 take away 49.5, which is 130.5 seconds. These are our first two answers, so that tells us that on its first revolution, the Ferris wheel reaches a height of 10.8 metres, first at 49.5 seconds, and then secondly at 130.5 seconds. That's what the question asked for, so that's the end of question number 9.